Hello, welcome back to Organic Chemistry Lecture Series. I've already finished watching part one of reactions with nitriles. In this video here, let's look at the reaction of nitriles with granular reagents and lithium hydride, right? And again, see some interesting mechanisms with these ones, right? As we saw before. So let's start with our nitrile going to react with a granular. R1 and R. And these reactions, the first step will be granular. Second step will be H3O+, right? Again, we'll see something a little interesting here because we're working with a carbon that's triple bonded to a nitrogen. So those reactions are going to be a little bit different, right? A little bit different, but a little more interesting, right, than we've seen before. Again, just kind of expands our mechanism abilities here, right, to do these things. So let's look at the mechanism of this. All right, as we first do this, what do you think is going to happen first? What do you think is going to happen? What do you think we're going to do with our granular? Remember, this is a strong nucleophile, right? Strong nucleophile, so that means it's going to attack something. What's going to be our electrophile in this? Which atom's going to be our electrophile, right? Just like we saw in our previous video, the electrophile is going to be what? It's going to be the carbon. Okay, and by doing that, we're going to push electrons to that nitrogen. Nitrogen's going to give it negatively charged. Okay, and now we get that negative charge on nitrogen. And so really, granular's job is done. It did its job. It delivered that R group here to that carbon. So it did its job. It's happy. It's fine. There's not much else we can do. We can't put another granular reagent here. We can't react that because it's going to make that too reactive. So we're stuck here. So we're at this spot here. Now, this is where our second step comes in. This is where we're going to start adding in our acid. Okay? Now we add in our acid. And so look at that. By adding our acid in there, we've now coated that nitrogen, and we turned it into what? Right? Something we've seen before. Our amine, right? We turned this into our amine. Now that we have this group here, what can we do next, right? Well, since we have this under acidic conditions, this is going to get hydrolyzed, right? Just like we saw in our previous video, right? You should be like, I've seen this before. If you see my previous videos, which I know you're watching every one of my videos, you know what's going to happen next, right? We can hydrolyze this, right? We can hydrolyze this. Now we have one pair of electrons. Let's go through this process again. I don't mind doing it. I like the mechanism. I can do these mechanisms all day, right? And look at that. Oh no, we have a positive charge on our nitrogen. What's going to happen now? Let's do our resonance. Electrons go up. Electrons go up. And positive charge there. Again, we have that positive charge there. Let's tack it with our water. Right? So now we've tacked it with our water. Now we have this positive charged oxygen here with hydrogens around it. What do you want to do now? We've seen this before, right? Seen this movie before. We're going to do a hydride transfer. I'm going to move my hydrogens over to make it look a little nicer. Right? We're going to do this hydride transfer. This nitrogen is going to pick up a hydrogen, and the electrons go back to the oxygen to make this species here. Now we generate what? Now our nitrogen is going to be a good leaving group, right? It's going to be our good leaving group now. So now that this group can leave, And we get to this species here. Now we have this positive charge on the carbon. What do you want to do now? Seen it before. Okay. Same thing, different movie, same thing. R1. Positive charge on our oxygen. The last step is going to be deprotonation. Let's deprotonate that. Let's take we use our mean. Generally, our means will be fairly basic enough to do this. So look at that. We've made our ketone. All right. So I can take my nitrile, react in my Grignard reagent. Second step is addition of H3O plus. We're going to end up generating a ketone. There's our R group that we put on from our Grignard, right? Our ketone. And really how this works is our Grignard is going to put a alkyl group on this carbon here, right? Which then is going to generate our imine. Once we have imine, under acidic conditions, it's going to be hydrolyzed to a ketone, okay? A ketone, right? Just like we saw before. This mechanism we've seen before in our aldehydes ketones section videos, right? So we can make our ketone from this. So it's pretty exciting. We can use our Grignard with our nitrile group to do this, right? Really, we can see this nitrile group as a pretty versatile functional group, right? We can already change it to lots of different things. So, okay? So this is with our Grignard doing this type of mechanism. So now let's look at what can we do if we have our nitrile now working with lithium aluminum hydride. Okay? That's our next one. That's where I started with. All right. Again, these are good mechanisms to do at home and try them yourself. I think it's good to start and watch the video, stop it, do the mechanism, and then look at the video again to see, am I doing the same steps that I'm doing, right? You watch these videos as much as you want, right? So, this one, again, we're not going to worry too much about the mechanism of this one, but very similar to what we saw with the other things is I can take lithium aluminum hydride. I take lithium aluminum hydride, right, in excess. And then I'm going to use additional water. And so what we can do with this one here is we actually convert this into our CH2 amine, right? Very similar to what we saw before, right? And we can imagine what's going to happen with this mechanism, right? This mechanism. We won't spend a lot of time talking about this mechanism, but this idea that I can take this lithium hydride using a strong reducing agent is going to add these hydrogens to this carbon here, right? Not once, but we're going to actually add hydrogens there twice, right? Add hydrogens there twice to give us this CH2, right? This lithium hydride is going to add these two hydrogens here. And then these two hydrogens here, for the mean, are actually going to come from water. It's going to keep deprotonating water, right? As we do this mechanism here over again, right? Do that one. It's not really that exciting mechanism because we're just going to add hydrogen twice here. And then nitrogens are just going to pick up two hydrogens, right? But this, again, is another mechanism we have, right? We can take RCN, we can take our nitrile group here, and we can reduce it down to a amine, right? Amine. So that's a nice way is if you wanted to put amine on something. You can use the nitrile group to do that, and then reduce it down to an amine here, okay? And once you have amine, we can do some other chemistry, okay? This is our other mechanism we can do with our nitrile reduction, all right? So look at two more mechanisms with our nitrile groups, right? We saw with acid catalyzed and the base catalyzed hydrolysis to make an amide, right? Then we saw with the Grignard reagent, we can then add in another alkyl group in there and then convert it into a ketone. Our nitrile, we can reduce it down with lithium hydride excess to give us an amine, right? So there's a lot of reactions that we went over in this section, right? With our carboxylic acid derivative. It's good to go back over them and just kind of practice recall in terms of being able to know reactants and with our reagents and give us our products, right? And then know if I have a product, where can that product come from? What reagents can it come from? In future videos, we'll talk a little more about this. Maybe we can go back over some of these or use these, right? We also got to go through and talk about carboxylates and enolates.